Welcome to the live interactive session for surface water hydrology being taken by Professor Dr. Rajiv Maiti from the Department of Civil Engineering IIT Kharagpur. I am the teaching assistant Aman Srivastava, and this is going to be the last lecture in the lecture series of problem solving session on Hydrologic Design Part 2. So let us focus on one of the aspects of intensity, duration, frequency curves. So today we will be solving one exhaustive problem on this topic, IDF curves. So let me read the problem for you. Refer to the following duration versus intensity information obtained from an IDF relationship at a location for a 10-year return period. In the design hydrograph with 50 minutes increments, determine the maximum 50-minute depth of precipitation for a 2-hour storm at that location for the same return period. So it says that there is a 2-hour storm, as we can see here, the duration in minutes. It starts from 15 and ends at 120 minutes, which indicates 2 hours of storm. Corresponding to each of the 50-minute duration, the intensity of the rainfall is mentioned here. So our objective here is to determine the maximum 50-minute depth of precipitation that has occurred across this 2-hour storm duration. So let us use this IDF information to arrive at the maximum 50-minute depth of precipitation. So let us design the hydrograph for which here one sample calculation has been provided for the first 2 rows. So this is what is actually given in the problem, that is 50-minute duration corresponding to which the intensity of rainfall is 72 mm per hour. Likewise for 30-minute duration, the intensity is 52 mm per hour. This is what is already given in the problem. Now what we need to estimate here is the cumulative depth. So let's see how that first row has been calculated for cumulative depth, how to find out its intensity into duration. So intensity here, it is already mentioned, mm per hour into duration, which is in minutes. So here the intensity 72 mm per hour has been multiplied with the duration in hours, such that this hour get cancelled out and we are left with only the depth. So this depth comes out as 18 mm. Likewise, for second row also we can estimate the cumulative depth, which comes out as 26 mm. Similarly, we can estimate the incremental depth using the information from cumulative depth. How to estimate that? For the first row, it is mentioned that the cumulative depth will be 18 mm because this is what we have obtained as the first information. Likewise, for the second row here, that is 26 mm, the simple subtraction between 26 and 18 mm provides the incremental depth at a 30-minute duration. Likewise, we can keep calculating the cumulative depth and keep calculating the incremental depth for all other durations until 2 hours of rainfall. So here it is summarized like what is a cumulative depth against each of the duration and incremental depth as well. Now what we are interested is to find out the maximum 50-minute depth of precipitation for a 2-hour storm. So if we look carefully for this incremental depth, the maximum depth of rainfall that we can actually observe is this 18 mm. I hope you are able to follow. So for any 50-minute duration, the maximum depth that could have been possible for the storm is the 18 mm depth of rainfall that we have obtained at the very first 50 minutes. So this is what is the final answer to this question. I hope you were able to understand the concept of IDF and also was able to deduct information from the problem of IDF and identify what could be the maximum possible depth of rainfall that is occurring in a given duration of the total storm period. Thank you.